doesn't flip for you, let me know. Okay, now the very important protocol in TCP/IP networks, that means the internet basically. When I say TCP/IP network, typically the internet is a not typically, exactly. Internet depends on TCP/IP. Internet runs on TCP/IP, right? So basically, this entire TCP/IP suite of protocols, not OSI, is what is implemented in the internet. So when I say the internet that we are using, right? So that internet. So that's the web browser that you use, but basically the network behind. So DHCP is a very important protocol. Why? Because DHCP basically provides network addresses, IP addresses to the new devices which have joined the network. So imagine like this, that you go and purchase a computer, right? Then you have to plug it in to the internet. Without the IP address, it cannot function. Understood? So where do you get the IP address? There are two ways. One is that manually you give everyone an IP address. You simply have to ensure that if I have given you some address, it is not used by somebody else. So manually, static, it is called static IP. So statically, manually, I give an IP address to every client, every host. IP addresses are required for the computer to connect to the internet. So the question is that one is static, we can do that. But what is the other option, which is much more popular? For this, we have the DHCP. So this DHCP protocol basically maintains a server. It is called the DHCP server. Now this DHCP server, whenever there is a new client which connects to the network, this DHCP server basically assigns an IP address to that client. You understand? Automatically. Okay. If at some point later on the IP address needs to change, the DHCP server will be contacted, and accordingly, without any human intervention, without any operator intervention, the new IP address will be received by the corresponding client. Okay, that's the purpose of DHCP. Now, DHCP works with a few major steps, the operation. That's the core, the heart of DHCP. But before we come to that, let us go through some of the basics. So as I was telling you that dynamic assignment of IP address. Dynamic means that now you need an IP address, later on it needs to change, automatically that change will happen. Dynamically the change is going to happen. Why it is required? Because sometimes for some applications IP addresses are required to be assigned on demand. You will avoid any kind of operator manual intervention in entering the IP addresses, because otherwise there might be some duplication of the same IP address, or even it is less manageable, right, with manual entry of IP addresses. And think about the mobility. Earlier days, nowadays it is actually not very popular, but there used to be something called mobile IP. That means that I move from here, I go to some other place, I plug in, and automatically I remain connected. Or even like through wireless, when I'm moving from one building to another, when the physical layer connectivity is there, the IP addresses will help in the mobility of my device. So what are the solutions for this dynamic assignment of IP addresses? One is RARP protocol. You know by now, we covered RARP when we were talking about ARP protocol. So what does RARP do? ARP protocol was that you have the IP address, you need to know the Ethernet address. ARP. RARP is the reverse ARP. That means that you have the Ethernet address. I purchase a computer, right? I plug it to the network. So the Ethernet and the network address is known, isn't it? The NIC address is known, NIC card address is known. That's the Ethernet address. Now I need to get an IP address. So RARP is a protocol that can help in this. So here also RARP also works in a manner conceptually which is similar to DHCP, which you will realize later on. So RARP also works on the principle of maintaining an RARP server, and that server is responsible for assigning the IP address. There is another protocol, there used to be another protocol back in the 1980s it started, and it was also popular for this particular purpose. It is called the BOOTP protocol, the full form of which is Bootstrap protocol, BOOTP. So the host in BOOTP can configure its IP parameters at boot time. So whenever the host boots up, automatically it will get the IP address and also do the necessary configuration. So BOOTP protocol offered three services. One is IP address assignment, the main purpose. Second is detection of the IP address for a serving machine. And number three is the name of the file to be loaded and executed by the client machine. So BOOTP protocol also used to be there. Its corresponding interaction details are given over here, but I am not going through it explicitly. So basically, no, let me do it. So this will help you to understand the DHCP better. So let me do it. Although it is a kind of obsolete, not obsolete, I mean not used much kind of protocol. So still, for the sake of understanding of your DHCP, let me go through the steps of interaction. So at the very beginning, each network participant does not have any IP address. The network administrator then provides each host on the network with a unique IP using IPv4 protocol. Next, the client installs the BOOTP network protocol using TCP/IP intervention on its computer system to ensure the compatibility with all network protocols when connected to this network. Then the BOOTP network administrator sends a message that contains a valid unicast address, and this unicast address is then forwarded to BOOTP client by the master server. Very simple, right? You connect, BOOTP server gives you the IP address. That's the main thing. So RARP concepts, BOOTP, etc. have been taken forward in DHCP to build a little bit more robust kind of mechanism for dynamic assignment of IP addresses, and that's called the DHCP. So whereas BOOTP started in 1985, DHCP is more recent. It started in 1993. Okay. So both DHCP and BOOTP, they use the same port numbers, and what are those port numbers? We'll come to it later. But DHCP has certain extensions which support temporary allocation of IP addresses. Temporary allocation is a very important feature to understand. It is also called leasing of IP address. Leasing of IP address means that if a DHCP server gives you a particular IP address, okay, you are leasing it from the server for certain duration of time. After the expiry of the time, either the address has to be renewed or you get a new IP address. Exactly the same way as whatever happens with the leasing in our day-to-day life happens over here as well. So the DHCP client can acquire all IP configuration parameters needed to operate. So DHCP becomes the preferred mechanism for dynamic assignment of IP addresses, and it can interoperate with the BOOTP clients. So basically you have BOOTP clients, you have DHCP server. So that sort of interoperability is also possible. But nowadays, basically, mostly everywhere, you will find that most implementations are dependent on DHCP. How many of you have heard about DHCP before? Have you heard of DHCP? You have heard of DHCP? No? You have heard of DHCP? So DHCP So whenever, so you are doing a configuration, right? You have purchased a computer, you have to connect to the internet. What do? You simply do not plug it in, right? You plug in, but then you have to configure. Otherwise, you cannot connect to the internet. So when you do this configuration, couple of parameters you need to enter, right? So you need to enter, for example, what are the parameters? Previous class I already covered. What are the parameters? Huh? Gateway address, right? Gateway. So, so what is the gateway address? Then what? DNS. Then you also need the net mask. Net mask, right? That will tell like which part of the network it belongs to, the net mask. Or it is also something sometimes, see, depends on whether you are using the fixed one or the this thing. So either it will be class full or classless, right? So basically the subnet mask. The subnet mask is required. So these configuration parameters basically, if you go to like so different ways actually you can do it in on Windows. One of the ways is that through your web browser, through the options basically, there you will be able to find where you can enter these configuration parameters. And other way also, you should be able to reach to that configuration menu. But for you actually life becomes easier because you simply get the services of the service provider easily, so that you do not have to do these configurations yourself. So this is very important. DHCP message format. What is there? Very interesting. You see, other things like opcode. Opcode means, so opcode. The first field is opcode. Opcode means operation code. Whether it is a request message or whether it's a reply message. Request message is 1, reply message is 2. Now what is this request and reply? We will come to it little later. But request means that I am requesting the IP address. Response is I am getting the IP address from the server. But I will show you the exact steps in a short while. So like this actually there is the hardware type like Ethernet, etc. Then the length of the hardware address. So like that actually few fields are there. But what I wanted to highlight over here is this field, the time elapsed field. This time elapsed field is basically the number of seconds since the client started to boot. And why is it important? It is important because the the IP address is basically given for a certain duration of time. It's leased. And few other parameters are also there. So which I'm not going through, but that doesn't mean that you don't have to go through, you have to go through. But these are pretty similar to the previous address fields for the other protocols, right? Similar in the sense like going through them is similar, but of course for every protocol the corresponding header format you need to go through separately. Now you see that over here in the message format there is an option field. Almost like every header you must have seen this option field. This option field is for doing what? For providing some optional information. So what is this optional information? This optional information can contain 3 fields: tag, length and value. Okay. So you see this tag is 1 byte long, length is 1 byte long, and then this value is a variable length field. 1 byte variable length. Acha. Now there are several tag fields that are supported by different vendors. Different vendors support different tag fields. Tag 53 is used in most of the cases. If this value is 53, then the value field can be, this value field can be one of the 8 types. Different vendors, different tags. Corresponding to the tag, you have certain values to be included. Now we are talking about, for tag 53, what are these different values? One is DHCP discover, two is DHCP offer, 3 is DHCP request, 4 is DHCP decline, 5 is DHCP act, 6 is NAC, 7 is release, 8 is inform. These commands, these messages will be used shortly in the interaction for getting the IP address using DHCP. So each of these message types, discover, offer, request, etc., their corresponding values are given over here. So this value is going to be 1 or 5 or whatever. So like this, these values are going to be. This is for tag 53. Different tags, different vendors, different support. So let us focus on only this one. So we will now use these message types in our interaction. And this is the heart of understanding of DHCP operation. DHCP operation is the heart of DHCP. So you have a client, you have a server. Client doesn't know its IP address. That's the problem, right? Client doesn't know the IP address. Client needs an IP address in order to get connected to the internet. So the problem is that client needs this IP address. The server's IP address is already designated. Server has a specific IP address. Now through the interaction between the client and the server, the client needs to get its IP address. That's the whole problem. So how it is going to happen? Through the interaction of these messages that are given. What are these messages? First is DHCP discover. So with DHCP discover message, you have different fields: transaction ID, release time, client address, your address, server address, source port, destination port, source address, destination address. For a few seconds, try to absorb the contents because this is very important subsequently. Release time is very important. DHCP works on the basis of leasing. So release time is very important. So in the discover message, we have, among the other fields, this release time. Not only discover message, all the other messages also. Release time will be carried forward. Now, initially, the client doesn't know any of these parameters: release time, client address, your address, server address. None of these basically are known. So it will send a, it will. So you see, with the source address this one and destination address this one, 255.255.255.255 is what? What type of address is it? Broadcast address. Very good. 0.0. Means own address. Okay, still we do not have the IP address. I mean, you just start from that point on. Then you broadcast. It goes all the way to all the nodes. Now this guy, so it is sent, right? So discover. Then it reaches over here. Then this DHCP server, it will know that it has to do something with that message because the purpose of it is to basically do is. So once it gets this broadcast message, through this DHCP offer, it is going to make its offer. Now you see all these fields which were blank over here are now filled up. So we have lease time 3600. This is what? In seconds. 3600 seconds. Client address, your address, server address. So you see this your address means this is the address, basically this DHCP server, it is giving to the client your address. The name is your address, okay. So it is giving this IP address to the client. Now here you see what is the source address. Source address is the server's IP address 181.14.16.170, right? And what is the destination? Again it is going to broadcast. Then this fellow, if he is happy, the client, if the client is happy with that offer, then it will set its address to this offer address, your address, which is 181.14.16.182, this one. And then the server address is also given, and then it sends the DHCP request with the source address, its own address, and destination address, the broadcast address again. Now, finally, this acknowledgement will be sent by the server to this ACK message, where your address is going to be confirmed, because this through this request message this was confirmed, and then the server address is also set, and the source address becomes the server address, destination becomes the broadcast. Why broadcast? Because everybody else also needs to know that this is the IP address that is given to this particular client. So that's why this broadcast mechanism is used to inform the others also. So this is the heart of DHCP. Remember this very well. Okay, at your homes, try to absorb and assimilate this thing properly. Discover, offer, request, act. So now, whatever I explained to you is given in more detail in these slides. Okay. So then this thing let me explain to you, this DHCP release. So, after the expiry of the lease time, or whenever the client doesn't need the IP address anymore, it has to release the IP address. This is done with the help of the DHCP release message from the client to the server. Okay, DHCP release. DHCP basically uses two ports. One is port 67, the other one is port 68. Two ports, designated ports, are used by DHCP. Normally, what did you hear in any client server communication? You know that one port is a well-known port, the other one is called ephemeral port, right? Client gets the ephemeral port and server well-known port. And there is a reason for it. We discussed it in one of the previous classes. No point in discussing that further. But what is important to understand is that in DHCP, we are giving a designated port also to the client. What is the reason for it? There must be some, there must be some reason. So this reason is given over here, but broadly it is like this, that in this communication process, unless you give a well designated port number to the client also, right, this sort of communication cannot take place. So this is a very important thing actually. More technical terms, what exactly happens is given over here, but what I just said is a summary of the entire thing. So you need to have a designated well-known port for this one plus this one. not a temporary port address for the client, as normally we do for client server communication. DHCP error control. DHCP uses UDP. It is not reliable. So in order to do DHCP, in order to do error control, DHCP uses two strategies. The first one is DHCP will require UDP to use its checksum. Previous lecture we have seen that the checksum field is optional in UDP, right? So if it is all zeros, then you are not using the checksum. But if you have to use DHCP, then you have to make UDP mandatorily use the checksum field, because DHCP itself cannot do error control on its own. So this is the first step. So how does DHCP do the error control? That it requires the UDP to use the checksum. Second, the DHCP client will use timers and a retransmission policy if it does not receive the DHCP reply to a request. So timers will be used. Okay. However, to prevent a traffic jam, when several hosts need to retransmit a request, maybe there was a power failure or something, everybody rushes to get the IP address from the server. So after such an event, basically there might be some kind of congestion. So DHCP forces the client to use a random number to set its timers. So every client basically will generate a random number, and the timer time will be set as that random number. This is the other important thing that you need to understand in addition to understanding the operation. And with this we will be done. So what is it? The transition states. What are these transition states? First is initialization. The client initializes itself. So the initialization, then selecting, requesting, bound, renewing, rebinding, and the corresponding transitions are given. When the corresponding state is triggered, that one basically so like this. So here I would like to highlight one thing. So when the lease time is 50% expired, then the DHCP client basically will send a DHCP request for renewal, and then it gets an acknowledgement. When the lease time is 75% expired, then this request is sent to the server, and then it rebinds, the client rebinds to the server, and then the corresponding ACK, NACK, etc. will acknowledge like whether it is successful or not. Okay, so this is the very high level kind of picture of these state transitions, and make sure that in your hostels basically you go through each state and the corresponding transitions in deeper detail. Okay, that's all. Any question? I will give priority to the online students because they are feeling like they are getting deprived. Online students, any question?